Okay, so let's finish this example by looking at the other three equilibrium points. Remember, we already found out that the point 0, 0 was a source node. So now let's take a look at the point 0, 5. So Jacobian at 0, 5 is equal to, and again, we're putting in 0 for x and 5 for y. So that's 2 minus 0 minus 5 makes negative 3. The x number is 0, so that will go there. The y number is going to be 5, so that's negative 4 times 5 makes negative 20. And then we plug in 0, 5 again. We're going to have 5 minus 2 times 5 minus 0, so that's 5 minus 10 makes negative 5. Once again, you'll notice that if we find our eigenvalues, that would be negative 3 minus lambda times negative 5 minus lambda plus 0 equals 0. So once again, you can read the eigenvalues as negative 3 and negative 5. So because these are both real and they're negative, we're going to have a sink node for this equilibrium point. All right, so let's move on now and take a look at the point 2, 0. Jacobian at 2, 0 is now going to have the x-coordinate equal to 0. So that's going to be using the same formula for Jacobian matrix. That's going to be 2 minus 2 times 2 minus 0. So that's 2 minus 4, which is a negative 2. The x-coordinate is negative x. It's 2. So that's going to be a negative 2. Let's just say that. And then the y-coordinate we know is 0. And then down here, that is 5 minus 2 times the 0 minus 4 times the 2. So that's 5 minus 8, which is negative 3. And once again, we can look at our main diagonal, and we notice that we have lambda 1 equaling negative 2, and lambda 2 equaling negative 3, and we have another sink node. All right, the last one to check out is the point 1, 1. When we check out the point 1, 1, we're going to have 2 minus 1. So that's a negative 1 at that location. We have a negative 1 up here. We've got a negative 4 down there. And then we've got 5 minus 2 minus 4. So 5 take away 2 is 3. Take away 4 more is negative 1. Now there's no zeros to take advantage of here, so we have to go ahead and calculate the eigenvalues the hard way. Negative 1 minus lambda. Negative 1 minus lambda minus 4 is equal to 0. Multiplying this out, we're going to have negative 1 minus lambda squared, and that's going to be minus 4 is equal to 0. Negative 1 minus lambda squared is equal to 4. Square rooting both sides. We're going to have negative 1 minus lambda equals plus or minus 2. So negative lambda equals 1 plus or minus 2. So lambda is equal to negative 1 plus or minus 2. Breaking it down, the first one is negative 1 plus 2. That's a 1. The second one is negative 1 minus 2. That's negative 3. Because we have 1 that's positive, 1 that's negative, we've got 1, 1 being a saddle node. So we've now classified all 4 of our equilibrium points. We've got 1 source node, 2 sink nodes, and a saddle node. So now let's go to the p-plane program and visualize all of this.